All right, here we go. We are reviewing 5.2, which is factoring quadratics. I've given my students a guided notes, which has 10 questions, so they won't have to write it down, each example as I go over it. Michael, read the instructions for 1 through 4 for me, nice and loud.
Factor the common factor out of each expression.
Okay, so circle this, highlight it, and write it down. Rule number 1 of factoring is GCF. Right? It doesn't matter how big the problem is, all 10 of these, you are always looking for GCF. GCF stands for greatest common factor, which means you are looking for the biggest value that goes into both of these. Right? It can be a number and a variable, it can be a number or a variable, it can be both. In this case, you're looking at 3n and 6, and you're saying what value goes into both of those, and what is that value?
3.
So we pull 3 out to the front. Somebody said in an earlier period, well, factoring is just the opposite of distributing. I agree. That's a great way of describing it. But we pull 3 out to the front, right? And then we have to figure out what goes here. Well, how do we do that? Well, we take each one of these terms and we divide it by the GCF. 3n divided by 3 is just n. 6 divided by 3 is just 2. And so our answer, when the directions say factor, is 3 parentheses n plus 2. How do we know that's the answer? If we were to distribute here and here, we would end up with the original equation, 3n plus 6. Okay? You try number 2. Right now at your desk, factor out the GCF on number 2. All right, you should be done at this point. Okay, you should be able to look at all 3 of those terms, 6b cubed, 24b, and 60, and figure out what's the GCF. Now, we may differ a little bit on this. You might have pulled out positive 6. I'm going to pull out negative 6. Tell me why it would be advantageous to pull out a negative 6.
Negative b.
It makes this value positive. And normally when factoring, you want A, right here, you want A to be positive. It makes no difference on this. The GCF is either 6 or negative 6. It really doesn't make a difference. But I'm pulling out negative 6 to kind of have as an example to see if you can get the parentheses correct. If negative 6 is my GCF, what value goes here? B cubed. Here's a question. Why wasn't B part of our GCF? If this one has a B and this one has a B, how come B wasn't in our GCF? I agree. The 6 was common. B was not common. Right? There is no B right here, so B is not part of our GCF. All right, Brandon, tell me the second term right here. Noah.
It'd be positive 4b.
Very good. Positive 4b. Why is it positive? Well, when negative 6 times positive 4 has got to give us negative 24. We have to make sure in our brains that this multiplied together gives us this. Okay, finish it out, Ballard. What would the last term be?
Plus 10.
Correct. Positive 10. How do we know that we have the right answer? We could distribute 3 times and we'd end up with the exact same thing. Okay? I'm going to give you a second here. I want you to try 3 and 4. Do both 3 and 4. Don't skip down. Don't do any others, but do 3 and 4 now at your desk. All right, so here we go. I know you may still be working. Bradley, tell me what my GCF is on number 3.
3.
How about V?
15 doesn't have a V, so it won't really count.
Outstanding. All right, tell me what's left inside the parentheses when I divide all 3 of these by 3.
5 plus 4V minus 4V to the 4th.
Outstanding. Exactly right. All we're doing is pulling out the GCF. In a minute, we're going to pull the GCF out and factor some more. But right now, we're just practicing on pulling out the GCF. Questions on number 3. Ian?
When did you write them in descending degree?
You can, and order doesn't really matter in you know, as long as you changed inside here. And descending order, if we were trying to actually factor, we would. But for this, for right now, nothing combines. We're not taking it to the next level. We're going to leave it like that. Great question. Okay. Quinn, how about number 4? What's different about number 4? They all have a V, not just a V, but a V squared. How do we know that? Well, this is V, 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 V. This is V, 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 V. This is V, V, V. And this is V, V. Right? They all have at least 2 V's in them. Right? The reason I did this was so that you could see how many were left. If I pull out a V squared inside the parentheses, that first one has got to be V cubed. Right? Because there was a total of 5 V's. So if I pull 2 out to the front, there has to be 3 right there. But in addition to V, what else is part of the GCF? 4. So 4V squared is the GCF. All right? Quinn, finish it out and tell me what's left inside. 3V cubed, I agree.
Plus 8V squared.
I agree.
Plus 10.
I agree.
Plus minus 5V squared.
Careful. Here, if we had V squared here, and we multiplied it by V squared, we'd end up with V to the 4th. So, and remember, we're dividing this by 4V squared. So these cancel and I get -5, but that's it. The V squareds went away. Okay? So always double check that this times this gives you this. And this times this gives you this. Just go back and quickly check and make sure that this times this gives you this. As long as you do that, you'll be in good shape. Okay? Questions? Any questions on factoring out the GCF? That's always rule 1. Say GCF.
GCF.
All right, everybody take a look at number 5. Michael Vecchio, read out, hold on just a second, read out number 5 for me. Nice and loud.
M squared
Mm-hmm.
plus 5m minus 24.
All right, I've got steps right here. Write these on your paper. Write these on your paper. Step 1, GCF. Steps 2, look at your signs. That's what plus and minus is there for. Step 3, take a look at A. And really, step 2 or 3 can happen at the same time. You know, they're not necessarily in order. 2 is look at the signs. Right, I have a plus or a minus there to tell you, look at these signs. Look there and then look there. Right, look at your signs. Step 3 is take a look at A. What is A? A is the coefficient in front of x squared. Sorry? Question? Okay. Step 4 says look at C and factor it. What is C? C is this value right here. Step 5, look at B. As you're factoring C, look at B. I mean, because let's face it, factoring is all about what 2 numbers multiply to give you this number and add or subtract to give you this number. I mean, that's really the mental jigsaw puzzle that you're trying to figure out. This 24 has lots of factors. Which one of them, which one of the factors will give you positive 5? Don't answer. But that's our mental question that we're asking ourselves. What's step 6? Every single one of these you can check. How are you going to check? Before we even start, what is our method to check factoring? We just distribute, right? Factoring is the opposite of distributing. If we want to check, we just distribute. Okay, so here we go. First step, GCF. Is there a GCF? No. So we put our parentheses like this. We look at our signs. This is where our eyes go first. If this symbol is negative, what does that tell me? They're different. What in the world does different mean? Well, that's real simple. One of them's positive and one of them is negative. If that symbol is negative, one of them's positive and one of them's negative, I don't have to go any further than that. I can stop right there and put a plus minus, or minus plus, makes no difference. Then step number 3, and like I said, these two right here can happen in either order. Take a look at A. What is A in this case? 1. That's the easiest type. If A equals 1, then that's the easiest type. What are the only two things in the universe that multiply together to give us 1m squared? M and M, right? So, guys, we have 6 spots. I just filled 4 of the 6 spots. I'm 67% of the way there. I've just got to figure out 2 more spots correctly. Okay? How do I do that? Well, step 4 says look at C. What is C in this case? 24. I break down C. Look, it says factor it. What are the factors of 24? 1 and 24. 2 and 12. 3 and 8. 4 and 6. Okay? Which one of those factors, step number 5 says take a peek at B. We're trying to get positive 5 in the middle. Which one of these factors will give us positive 5 in the middle? I think these two factors. This gives us 10 or 14. This gives us 23 or 25. This gives us 10 or 2. This will give us 5 if we make this one negative and this one positive. We're trying to get positive 5, so we got to figure out what combination works. If we need a negative 3 and a positive 8, does that tell me what has to go in these spots?
Yes.
Positive what? 8 and negative 3. Positive 8 times negative 3 is negative 24. Positive 8 minus 3 is positive 5m. Okay, last step. What should we do? Check. How do we check this? Not solve. Distribute. There and there. M times M is M squared. M times negative 3 is negative 3m. 8. Distribute. There and there. Positive 8m minus 24. Combine like terms and I get m squared plus 5m minus 24. Is that what I started off with?
Yes.
Then I know I've factored it correctly. Okay, I know that I've factored it correctly. Okay, you try number 6. I just did number 5 for you on your sheet. You try number 6. Don't skip ahead. Just do number 6. I'll leave this on the board just for a second. I want you to try number 6 now at your desk. All right, here we go. First step. What's always your first step? GCF. Is there a GCF?
No.
No, there's no number that will go into all 3 of these. So we move down to the next step, right? We make our parentheses. We look at our signs. Uh-oh, this one's different. If this symbol is positive, immediately what does that tell us? No, it does not tell us that.
I mean, the same.
It tells us that they're the same. Same means both positive or both negative. All this tells us is that they are the same. Then our eyes have to look at the first symbol to tell us if they're both positive or both negative. Right? Look at number 7. What is it? What are they going to be? Wrong. Number 7. Look down at number 7. What are the symbols going to be on number 7? Plus, minus. What about number 8? Plus, minus. What about number 9? Plus, minus. What about number 10? Plus, plus. Right? We should instantly be able to look at the problem and tell the symbols. Right? That is an easy part of this equation. All right, step number 3. What do we do? Step 3, what do we look at? A is 1. That means it's easy. That means I can immediately put an M right there. M. Done. Step 4, what do we do? Start breaking down C, right? Start factoring C. Our eyes should go right here just for a second. What value are we shooting to add up to? Negative some value and negative some value is going to multiply to give us 70, but it's going to add up to how much? 17. So when I start out and I say 1 and 70, I immediately know that's not going to work. If I do 2 and 35, I know instantly that's not going to work. If I do 5 and how much? 14, I'm getting close to 17, but that's not going to work. So then I try, 7 and 10. That multiplies to give me 70, and it adds to give me 17. Y'all laugh, right? But that's a mental jigsaw puzzle. It's just like when you're doing a jigsaw puzzle and you see the piece that fits, right? And Dora's all going to be filled in, and you're going to have the jigsaw puzzle done, right? That's the same thing here. When you are factoring, it may take you a little bit, 30 seconds or more. Don't have fatigue during the problem and get tired and say, oh, I'm never going to get the answer. Keep working, because this number may be a bigger number, 196. And there's lots of factors of 196. And you have to keep working and keep working and keep working and keep working. Don't give up if you don't immediately figure out what factors work. Okay? So 7 goes here and 10 goes here. Are we done?
No.
What do we need to do in order to quickly know definitively whether or not we got the right answer? How do we check? Boom, boom, right? M is the M squared, minus 10M, minus 7M, plus 70. I combine like terms and I get negative 17M. It checks. That doesn't take very long. And it's practice on multiplying by numbers. Okay? All right, everybody take a look at number 7 while I write it on the board. Don't yell anything out, but ask yourself what is different about number 7. Don't yell anything out. Just look at number 7 and say, how is number 7 different? Why would Coach Collins have put number 7 on there as an example for us to practice? Don't yell it out. Look at it. Morgan, how is number 7 different?
There's a 2 in front of it.
So A is not equal to 1. Right here when we say look at A, that's why I said it can happen at the same time. Exactly right. A is not 1, so it's different. It's harder. There's an extra step that we have to do. Step 1, though, is still what? GCF. Is there a GCF? No. Why not? Why is there no GCF? 2 and 11 are prime, and they, there's no value. You can stop right there. Okay? We don't have, if this isn't even, we can stop. We don't even have to look at that one. All right, so we do our parentheses, right? We figure out our signs are plus or minus, but then this A is messing stuff up. We much would prefer A to be equal to 1. Much easier when A is equal to 1. So the trick is to make A equal to 1 by taking A and multiplying it by C. You take A, when A is not equal to 1, write this down. When A is not equal to 1, you multiply it by C. And that really can go right there. It's like a 3B step. If A is not equal to 1, you multiply it by C. That gives us n squared minus 11n minus 42. We have used a trick to make the problem easier by making A equal to 1. Now it's just like 5 and 6. It's like those easy problems. We break down 42. What does 42 break up into? Well, 1 and 42, 2 and 21, 3 and 14. Uh-oh, we're trying to get 11 in the middle. One's positive and one's negative. We know we got n here and n here because a is equal to 1. These factors will give us 11, but I want negative 11. So if I want negative 11 in the middle, what value needs to be positive? What value needs to be negative? The 3 needs to be positive and the 14 needs to be negative. Okay, are you with me? Does anybody have a question so far? Are we done? Is this our answer? If I multiplied these two binomials, would I end up with the original equation?
No.
No, I would not. Right? We've done a trick, and we have to undo that trick. In the first step, we multiplied by a. What do we need to do now? Divide by a, which was 2, and divide by a, which is 2. Write that down. You're dividing by a. Does anybody remember what comes next? How do I finish this problem? You're right. You simplified this. What does that mean? Well, if it's 6 over 4, I would simplify. Or if it was 9 over 6, I would simplify. Well, that doesn't simplify. 3 over 2 is in its lowest form. What do I do with the 3 over 2? Does anybody remember?
You take the 2 and you move it to the next one.
That's right. Why do you move it out front? Why do you move the 2 but not this 2?
That goes in the front.
That's right. All right, so listen, this is me saying, if this number does not evenly divide into this number, it simply goes right there. And I rewrite as 2n plus 3. This number evenly divides into this number. This is just n minus 7, and I'm done. How do I know that I've done it correctly?
You plug it back in. Distribute.
Distribute. I distribute to check. This times this is 2n squared. This times this is negative 14n. This times this is plus 3n. This times this is negative 21. These combine to give us negative 11n. So it checks. Okay? Questions? The one thing that I caution you about is if this number right here, let's just say that it was 6 over 4. You don't take that 4 up and put it right there. What do? You simplify into 3 over 2, and a 2 comes up and goes right there. So be very careful about that. Try number 9. It's like that. Try number 9 now at your desk. What's step number 1? GCF. Don't forget. Okay? Just because they don't have GCFs, don't forget step 1. Try number 9 now at your desk. All right, first step. What's always your first step? Everybody say it. What's your first step?
GCF.
Be thinking GCF. Okay? What's the next step? Well, you do your symbols. You also take a look at A. A is 8. If A is any number other than 1, we do what with it? We multiply it by C. So I have n squared minus 26n minus 56. Then you do your parentheses and n and plus and minus. Right? You can fill all of that in instantly almost. Then what, Lundy? What's the next step? Everybody gets to this and they stall out. What's the next step?
Find the.
Shh. Lundy, what's the next step? So in C, in this case, is 56. So we take 56 and we break it up and we say 1 and 56 and we say 2 and 28 and we say 3, I don't think goes, 4 goes 14 times. What am I trying to get to? Uh-oh. I'm trying to get to 26 in the middle. Any of those factors maybe give me 26? Which one? This factor right here will give me 26. If I manipulate it correctly, I need to get to negative 26. How can I take these two numbers and make them negative 26? That one needs to be positive and that one needs to be negative. So positive 2 needs to go here and 28 needs to go here. Okay, I'm almost done. I have to undo the magic trick that I did at the beginning. The magic trick made the problem a lot easier to factor, but it messed things up. Okay, and so I have to undo it. If I multiplied by 8, what do I need to do now? Divide by 8, divide by 8. Here's where some students mess up. They say, ooh, 8 doesn't go into 2 evenly, and they put an 8 right here. They say 8 doesn't go into 28 evenly, and they put an 8 right here. But what's 8n and times 8n? 64n squared, and that's not what we started off with. If you do that and don't cancel, you will not get the right answer. You must simplify, simplify, and I'll even write it down. 1/4 and n minus 7 over 2, I think. You must cancel both of those fractions into their lowest forms. Now, does 4 go into 1 evenly? No, it does not, so we say 4n plus 1. Does 2 go into 7 evenly? No, it does not, so we say 2n minus 7. Proctor, how could I quickly check that and make sure it works?
By distributing.
By distributing, right? How many times?
A lot. 4.
4 times, right? And that takes you literally 10 seconds. Okay, questions? All right, try number 10. Everybody try number 10 at your desk.